Hello students, you are welcome once more to your mathematics lessons. We shall start once again from where we stopped last time. The assignment was given to you to get the coordinates of those points lettered from A to Z. Today we are giving you the result of those, the exact coordinates of those points. So you take note as we reel them out. A is the point 2, 10, because the perpendicular line passed through the x-axis where the value of x is 2, and the horizontal line passed through the y-axis where the value of y is 10. That is why the coordinates of that point A is 2, 10. In a similar way, B is minus 2, 7, C 11, 1, D minus 8, minus 4, E 4, minus 4, F minus 6, 5, G 4, 6, H minus 3, minus 6, I 7, 4, J minus 4, 2, K 9, minus 5, L minus 4, minus 2, M minus 3, 6, N 3, 3, O 6, minus 6, P 9, minus 2, Q minus 3, 5, R 8, 8, S 2, minus 5, T minus 5, minus 3, U 6, 1, V minus 6, 1, W 2, minus 1, X 2, 5, Y minus 3, minus 4, and Z 6, minus 2. In all these cases, the first thing we did was to determine in which quadrant the point is located. Is it in the first quadrant, as I told you, positive for x, positive for y? Is it in the second quadrant, where I told you it is negative for x, positive for y? Is it in the third quadrant, where both x and y values are negative? That is negative for x, negative for y. And in the fourth and last quadrant, that place x is positive and y is negative. So once you master this, then the next thing is to check at the point, trace a line perpendicular to the x-axis. Where does it pass through? That is the value for x there. Check a line horizontally to the y-axis. Where does it cut the y-axis? That locates the y value at that point. That is what we did. Now, the use of this coordinate geometry in solving simultaneous equations. Let us consider one case, and then from there we can consider some other subsequent cases. We are given equation something like this. To solve the simultaneous equations, and I'm going to write them using the graph. Mathematics. Use of coordinate geometry in solving What are we solving? Simultaneous. Simultaneous equations. The equations may be linear, they may be quadratic, they may be cubic. All we know that is we use the graph in solving them. In this particular case and at this level, we're only concentrating on straight line graphs, what we call linear graphs. Now let's take two examples and see what it looks like. We have example 1, y plus 4 is equal to 2 minus x. Example 2 is y minus 2x is equal to 4. In each of these equations given, equation 1 and equation 2, the power of y is 1. The power of x is 1. That is why we say that they are linear equations, where the powers of the variables are exactly 1. Right. In order to solve this, we will need to take some points that will lie on this. Those points agree with the line. So we call them collinear points. Points that have agreed amongst themselves to be on a straight line. Collinear points. Collinear points. That is what we will look for here. Collinear points. That is what we look for. Since this is a straight line, we don't require so many points. We require just 2 points. Because with the 2 points, we can connect the straight line between those 2 points. Because, now, let's take for equation 1. Points for 1. Points for equation 1. Now, we will assume x to be 0 and ask ourselves what will y be. So for the first equation, let x be 0. You put 0, comma. We want to find the equivalent of y when x is 0. We put 0 here. So y plus 4 is equal to 2. Therefore means that y is equal to minus 4 plus 2, and y will be minus 2. So that's how we got that. That is 1 point. We cannot draw a straight line with only 1 point. We need another point so that we can use the ruler and join those 2 points and produce any side where we like. See, we've made x 0. Let us try to make y 0 and see what the corresponding value of x would be. So y now is 0. Come here, plug in 0. Then we will then have 0 plus 4 is equal to 2 minus x. X is minus x, so we'll transfer it to the left-hand side, so it becomes positive x. And then on the right-hand side, we have plus 2 staying here. Then plus 2 coming over there will become minus 2. So we have plus 2 minus 2. So in that case, that the x will become minus 2. So we've gotten 2 points there. First point, 0 minus 2. Second point, minus 2, 0. These are the points that will be on the graph representing the first equation. Let's take points for 2. Points for equation 2. Remember what we did in equation 1? We repeat that in equation 2. Look at equation 2 there. Assume x to be 0. Okay, let x be 0. Then what will be the corresponding value of y? So plug in 0 here for x. You have y minus 0 is equal to 4. So y minus 0 means y. Therefore y is equal to 4. So the value of y there is 4. Now we go again. This time around, we are going to let y be 0. If y is 0, then what will become of x? Put 0 here for y, then you have 0 minus 2x is equal to plus 4. Transfer minus 2x to the right-hand side, it becomes plus 2x. Then plus 4 will go to the left-hand side and become minus 4. If 2x is equal to minus 4, then x is equal to minus 2. So we have that. That is what we have. And then having gotten that, we go to plot our graph. And our graph is exactly this shape that we have on the board. That's exactly what our graph looks like. That is what the graph looks like. And what are we seeing there? Let us make short what we have. That's what we have. 0, 0. You have here 2, here 4, here 6. You have here minus 2, here minus 4, here minus 6. What about this side? We have 2, 4, 6, 8, 10, and so on. That is for our y-axis. We repeat the same thing here. You have minus 2, minus 4. And when we plotted the first one, 0, minus 2. 0 there, minus 2 there. Then the next one, minus 2 for x, minus 2 for x, and 0 for y, there. So when we join these two lines, these 2 points, we produce. That is the first equation. Y plus 4 is equal to 2 minus x. Then we plot the second one. 0, 4, 0 for x there, 4 for y there. We plot the other one, minus 2, 0. We go to minus 2, and it is 0. So that's same point again. That's what we have. This is the next equation. Y equal to y minus 2x is equal to 4. So from what we have drawn now, what we have sketched on the board, you can see that these two lines, straight lines, are crossing each other at a given point. And here on the board, they are crossing at minus 2, 0. Therefore, means that minus 2, 0 is on both graphs. And that is what they are asking you to solve. Find a point that is on the two graphs. One point. You find it in graph 1. In graph 2, line 1, it is still there. In line 2, it is still there. That's what they are asking. Therefore, the solution to this is a common point. Common. And that particular common point is the solution to these two linear equations. Now, this may not necessarily be easy. This is only a coincidence that what we have demonstrated on the board, you have value of x, positive, no fraction. Value of y, positive, no fraction. Certain times you get the values, both of them being negative, or both of them being positive, or one of them being either positive or negative. Certain times you also have these values being fractional. And the most difficult one is when you happen to get difficult fractions. Fractions that are very hard to handle. Let us look at such fractions that we say are difficult to handle. The fractions difficult fractions in plotting our lines. We want to take example. And the examples are like this. 3 over 7, 7 over 9, 5 over 6, 5 over 13, and so on and so forth. If you have such fractions, you cannot plot 5 over 6 of a line or 5 over 6 of a distance. You can't plot it in the graph. Suppose you have 3 whole number 5 over 13. Where will that 5 over 13 be? It will lead onto assumption. It will lead onto approximation. You look at it, doesn't say approximately this. And when you plot it, the answer or the final solution you will get from your graph will be wrong. Because I've already started on a wrong premise. Then what do? We are now concluding that it is not always that the graph which we use will give us accurate answer. The graph will be giving us approximate answers. But we want the real answers. In everyday life, we want real values. And that is why some engineers, when they do some approximations to whatever they are doing in the building of a house, because the thing is not natural. What they are doing is not natural. You have building collapses. So we want precision. Exact. If we want precision and exact, we will then use another approach to what we are doing. Remember, the topic is use of coordinate geometry in solving simultaneous equations. So let us look at other alternatives apart from plotting the graph. Which other alternatives are available to us? There may be many. We don't want to bother ourselves about how many there are, because as you go on higher, you will come across matrices, and then you start using that one again. But now we shall do to real solving, what we call analytical method, real solving, mathematically solving it. Analytical method. And in that analytical method, we have two types that we want to consider. One, or A, is That is how I call it. I continue calling it like this until 6 in. Elimination. Elimination. So, once you do it, you will always remember the spelling. Elimination. What does that mean? If there are 2 letters, make 1 letter to disappear. You have eliminated that one. Then 1 letter alone will remain. Then you solve what is given in terms of that letter that remains. That is what we call that elimination method. So we shall take 2 linear equations now and see what would happen. The first one is 2x plus 4y. 2x plus 4y is equal to 6. That is equation 1. The second one is x plus 5y is equal to 10. And we call that equation 2. Now, if we were using the graph here, we may be having numbers that will be convenient, but when we're in plotting, but when we want to read the answer, we enter into difficulty because it will be giving us 3 over 7 or 3 over 5 of a space. You can't read the exact value there. You'll be making some mistakes. That's why we are using this. Now, in elimination method, you have to note the following points. The coefficients of the letters. Coefficients of the letters. Watch. What are we watching? Or consider. Coefficients. of the letters. Very, very important. That is first thing you look at. A, consider coefficient of the letters. B, watch their signs. That means the signs in front of those letters. Here, X is positive in the first one, X is positive in the second. X is positive, Y is positive in the first one, and Y is also positive in the second. So we don't have any problem. But if we are doing this, and one of them is positive in one equation, negative in the other equation, that is the one you eliminate. It makes the solution easier. It doesn't mean you don't have other methods of doing it, but that is what makes it easier for you, so that you don't enter into much calculations later. When, let's say, X is positive in one, negative in another, eliminate X. Or, Y is positive in one and negative in the other, eliminate Y. That is why these two things are important. Consider coefficients of the letters first, then watch their signs. I have treated their signs. Then what are we going to do with the coefficients? Looking at the coefficients here, in the first one, the coefficient of X is 2. In the second one, coefficient of X is 1. In the second one, coefficient of Y is 4. In the first one, coefficient of Y is 4. Second one, coefficient of Y is 5. You can see that the coefficients of Y are higher than that of X. Eliminate the one with smaller coefficients. Eliminate the one with the smaller coefficient. That makes life easier for you. Therefore, I'm going to eliminate X. So you must determine the one you're eliminating, so that life will be easy for you in the calculation. If you don't, you will be involved with very big numbers in your calculation, and you may finally give up. All right. So what are we eliminating here? X. Why? Because the coefficients of X, both in equation 1 and 2, are smaller. That is why we're eliminating X. Okay, eliminating X. We now watch those coefficients. In the first one, the coefficient of X is 2. In the second one, the coefficient of X is 1. Then we must make them have same coefficient. To make them have same coefficient means we shall look at the LCM of 2 and 1. The LCM is 2. So, that 2 can divide it without a remainder. That 2, 1 can divide it without a remainder. So, we now go ahead and say, if 2 divides 2, what answer will it give us? 1. It means that this one remains as it is, because we have to multiply equation 1 by 1. Then, for equation 2, the coefficient here is 1. If 1 divides 2, what is our answer? 2. Therefore, equation 2 must be multiplied by 2. When you use the coefficient and divide the LCM of what you want to eliminate, whatever it gives you is what you use in multiplying across. All right. So, here now, I will have equation 2 has to be multiplied by 2. Watch the sign that I have used. You don't write these things in words. They will make a lot of problem for you. Just in short representation of your information. So equation 2 multiplied by 2 gives me 2x plus 10y is equal to 20. This is a new equation on the board. That is why I'm giving it the number 3. It's a new equation. So you number as new things arrive. You number like that. Now, let's look at equation 1. Coefficient of x is 2. Let's look at equation 3. Coefficient of x is 2. It therefore means we have brought the two coefficients to the two equations to the same coefficient. If that be the case, now, let's go to the coefficients of y. In equation 3, coefficient of y is 10. And in equation 1, the coefficient of y is 4. So 10 is bigger than 4. When they have the same signs, to eliminate, subtract smaller from bigger. When they have the same signs, to eliminate, subtract the smaller one from the bigger. Okay, so here now I have equation 3 is bigger than equation 1. So I'm subtracting equation 1 from equation 2. 2x minus 2x, that is gone. It's eliminated now. 10y minus 4y gives us 6y. On the constants, 20 minus 6 will leave us with 14. Therefore, this means that Mr. Y is equal to 14 all over 6. Don't leave it like that or reduce it to mixed fraction at the end. So, 2 here is 3 and 2 there is 7. 7 over 3 gives us 2 whole number 1 over 3. That is the value of y. That is the value of y. We need to get the value of x. We need to get the value of x. Where are we going to? We have 3 questions on the board. 1, 2, 3. Where shall we substitute this thing so that our x will come out? See, this is y. Then go to the equations on the board and look for Mr. Y. Look for Mr. Y in the equations on the board. You see here 10y. You see here 5y. You see here 4y. Go to that place that the y is smaller. Why we are taking smaller coefficients is so that you can multiply. So that it will be easy for you to multiply. That is why we are looking for the smaller values. So we substitute in equation 1. Substitute 4. Forgetting y nebe in equation 1. If you do, what happens? You rewrite that equation. That will become 2x plus 4 of y. What is y? Y is 2 1/3, which is 7 over 3. That's what we have. Is equal to 6. Then we start simplifying. Simplifying now, we write here 2x plus 4 times 7 is 28. All over 3 is equal to 6. Now, 2x we know will then be equal to 6 minus 28 all over 3. And that is the same thing as plus 6 minus 9 1 over 3. 3 into 28 is 9 times, which is 27, 1 remaining. So that's what we have. If we should simplify this now, we will then have that 2x is equal to minus 3 1 over 3, which therefore means that Mr. X alone will be equal to minus 10 over 3. That is 3 1 over 3 that I'm changing into improper fraction. I'm dividing by 2, therefore times 1 all over 2. 2 here 1, 2 there 5. So this now gives me minus 5 all over 3. And which will give me minus 1 whole number 2 over 3. That is the value for our x. Whereas this is the value for the y. You can see, as I told you, those difficult fractions. Can you see 1 over 3? Can you see 2 over 3? They are very difficult to plot. Even if you plotted the graph to read 1 over 3 there becomes very difficult. You can even say 9.5, which is not true. That is why the analytical method is brought. This method which we have used now is called the method of elimination. I want to discuss it once more. Consider the coefficients of the letters. When you have that the coefficients of the letters are positive, all of them, then you are going to eliminate by subtraction. And how are you going to eliminate by subtraction? You then look at the smaller coefficient. The letter that has the smaller coefficient, let it go. That is the one that should go. Always look for the smaller one, so that the problem will continue solving itself. But if in one equation the letter has positive, in another equation the letter has negative, look for that letter that is behaving that way, because it's a troublesome letter. Ta, positive, H, negative. Mba, oge nye gị nsogbu. Jide ya, may eliminate. Obuomad. So that is the process for that. We are going to do this same problem. This same problem we are looking at. We are going to take another approach to it. Not elimination now. We shall go to another one, which we call substitution. Substitution. Samuel, you pay attention. Substitution. The first one we called elimination. Elimination. But this other one we are calling what? Substitution. I decided to do this wait a bit so that those slow writers can finish writing, so that we can wipe out this. I hope everybody's through now. Davidson, you are through? Okay. So we can now wipe out this and go to the, see, we are finished with elimination. We now want to go to B. The A is elimination. We want to go to B, and B says substitution. Substitution. Shall we get the same answer? To the problem now using substitution, shall we? We don't know. Let us write there. Substitution. That is the substitution method. Let's get that problem up again and see what happens to it. The problem that we had there was 2x plus 4. 2x plus 4y is equal to 6. And we called it equation 1. The second one was x plus 5y is equal to 10. And we call this equation 2. The same equations that we had before. Can we solve them by an alternative method? Yes, we can. And we say that this is called substitution method. In this case, we have to make one of the letters given for the linear function that we have now, linear graph or linear equation. And you remember I told you the linear equation, the power of the two letters involved in that are all 1. That is what makes it linear. So looking at that, decide one of them to be the subject of the equation. Either x being the subject. By that we mean put x on one side, let every other thing go to the other side. Or y, the subject. And you know that we have always been saying y equal to. So that is why you see in most textbooks to use y to do it. But it doesn't mean that it has to be y always. You can use x. But to conform with the textbooks, we are using y. So, for the first one, equation 1, we will make y the subject of the equation. And if we do, we have 4y will be equal to 6 on this side minus 2x. Then we'll work again to produce only y. So that will give us y will be equal to 6 minus 2x, provided that you divide by 4. We repeat the same thing for equation 2. We'll also have 5y is equal to 10 minus x. But we want y. Therefore, y alone will be equal to 10 minus x all over 5. Now, you may decide to make y the subject of the equation in one of them. But I decided to put the two of them so that you see, you can use the new equation which you have now and work on any of them. So, y is equal to this is a different equation. We call this equation 3. Whereas this other one is equation 4. So we now have 4 equations on the board. Now, we shall use equation 3 on equation 2. Or we can use equation 4 on equation 1. Have you now seen why I decided to make y the subject of the equation in all of them? After making it, don't take 3 to 1, 4 to 2. That place where you derived it, don't go there to work it. Take it to the other brother. That is why 3 will work on 2 and 4 will work on 1. Okay, let me take 4 on 1. I write here, substituting, st, 2, 10, 4. That equation 4 says y, substituting for y in equation 1. You see how we write it so that the whole thing becomes very easy for you to follow. We are not writing essay where you'll be writing everything. You use short form to denote what you have. So if we do that, what happens now? We will now have it that 2x plus 4 of y, but remember our y now is 10 minus x all over 5. That is what our y is. Then the answer is equal to 6. We took 4 against 1. We can take 3 against 2. It will still give us the answer. Don't take 3 against 1, 4 against bam. Don't substitute in the very place where you made the subject of the equation. Carry it to the next brother. Alright. So looking at this now, I now have it that 2x plus 40 minus 4x all over 5 is equal to 6. So 2x over 1, 6 over 1. All of them now has denominator. First one, 1, the other one, 5, the other one, 1. So, we look for the LCM of these denominators. LCM is 5. Therefore, we are going to multiply across by this LCM that we have got. See, if we do, this becomes 10x plus 40 minus 4x is equal to 30. It's equal to 30. That's what we have. We have eliminated the fraction. We have removed the fraction. So we now need to simplify. 10x minus 4x is 6x. Then this side is plus 30. But the plus 40 going over there will become minus 40. So you now have 6x is equal to minus 10. Therefore, Mr. X is equal to minus 10 all over 6. Reduce minus 5 all over 3. Reduce minus 1 whole number 2 over 3. That's exactly what we had before for our x. You can see the elimination process. Now we've gotten this answer. Having gotten this answer, we need our y. Then the question now is, which y did we take? Was it y3 or y4? Even though each of the y's will solve it, go to the place where you got that your y. The y we use in solving now was y4. So go to y4. Substituting for x now. Substituting for x in equation 4. Then y there will be equal to 10 minus into minus 2 over 3. That's what we have there. all over 5. Minus it to minus will become plus. So this is equal to 10 plus 1 whole number 2 over 3 all over 5. That is 11 2 over 3 divided by 5. 11 2 over 3, write it in improper fraction. You have 35 over 3. 35 over 3. Since I'm dividing by 5 times 1 over 5. 5 here 1. 5 into 35, 7. 3 into 7 will give us 2 times 1 remaining 1 over 3. That's exactly the solution that we had when we were doing elimination. This one here is called substitution. You make one of the equations, you make the letter, a letter there, to be the subject of the equation. Once you get whatever that letter is representing in terms of its component letter, carry it to the next equation and solve. Not on that equation again. We made y the subject of the equation in equation 1 and we had y3. So carry y3 to equation 2 and solve. We made y the subject of the equation from equation 2 and got y4. Carry this y4 to the first equation that is given and solve. That is what we have. And we shall be having the same answers. So, we have learned 3 ways of solving simple linear equations. We can solve them graphically, and we have shown how the graph works. And we said that the graphs can be disappointing. And the reason we gave for the graphs being disappointing, you can find it difficult to get the points that will be on the graph so that you plot. You'll be having fractions, difficult fractions you don't know how to handle to plot on the graph. Or you may have simple numbers to plot on the graph, but while trying to read the answer, it gives you fractions that are too difficult, and you start approximation. That is why we say graph has a limit to which it can help us. But we then decided to solve ordinarily, which is what we call analytical method. That is method of solving mathematically. Then solving mathematically, we have 2 ways. 1, elimination. 2, substitution. Elimination. We mentioned what and what is involved in elimination. Write down the equations properly as given. Consider the coefficients. Why are we considering the coefficients? So as to know which one to eliminate. The letter with the smaller coefficients is the one to go. If the equations are both positive, we eliminate by subtracting smaller one from bigger one. If we have 2 equations and a letter in one of them is positive, in another equation it is negative, that particular letter is a problem letter. Very problematic. Here is the one to go, so as not to cause confusion. And in that particular case, you eliminate by adding, so that that will go out after you must have corrected the coefficients to the same size. All right. Let us have some problems set out, which you are to attempt. But before you attempt, there are just very few problems. Very few problems to attempt. Very few. Just 5 little interesting problems to tackle. 5 little interesting problems. So, let's write them down. You are to solve this by any method. Solve. Not graph. Oh. Graph is difficult. Solve by elimination or substitution. Substitution. Number 1. No, A. Not 1. A. 3F plus 2Y is equal to 12. That is equation 1. Then 5F plus 3G, 5F plus 3G is equal to 1. That's equation 2. B, 2x minus 5y is equal to 15. This is equation 1 here. Then 4x plus 3y is equal to 4. This is question 2. Then C, 4e plus 3f. 4e plus 3f is 9. That is equation 1. Then 2e plus 5f. 2e plus 5f is 15. That is equation 2. Then we take D. 9x minus 7y is equal to 33. You can see such number. If you are trying to use graph like this one that is stated here now, you will sweat too much. 3x minus 9y. No, 7x, okay, minus 9y is 15. Question 2. Now, before writing this last one, I want to remind us that when the linear equations are fractional, remove the fractions by using, there's an example that I did here as we were solving, by using the LCM of the denominators to multiply across. So I want to test it here. Just 5 little interesting problems. You have to do them immediately you see them. Now that we have just finished the lesson, you don't allow them to stay till the following day. Take your piece of paper, work on them because you have just listened to the teacher, fresh, and the thing will be fresh in your memory. And you just work on it. But if you keep it, and then say by tomorrow, in the morning, I will start off. As they are saying that, by the time you finish eating this afternoon and this evening, 1/3 of what you had will disappear. And the following morning, somebody will visit you when you are trying to do it. And that person's name is confusion. So do it now, so that Confusion does not visit. That's for this. So I wish you good luck as you're working on it. Work very hard, though. Don't be moving about. You know this dangerous man is hanging around. They call him Mr. Koro. So that he does not koro anybody. God forbid. Bye, and see you during the next lesson.